Okay, so we're now on to the neoclassical model, and I think I've just changed my mind what I'm going to go through. Yeah, I changed my mind. I'm going to take you through some of the basics of the neoclassical model. Okay. So the neoclassical model, we say that production Y is a function of effective capital and effective labor. So K is the number of sort of machines, if you like, or the number of widgets you've got in the production sector kept back in the factories. AK is how productive they are. L is the number of workers. AL is how productive they are. And Y is the number of widgets you're producing. So basically, we've got, can you see this? I think so, yeah. We've got households and firms. Workers are going off to the firms. The firms produce output. Some of it gets sent back to the households in the form of consumption goods. Some of it gets kept back in the firms to build up capital goods. But there's only one product, and Y is the quantity of that product. Two uses for it. One, kept back to help future production. The other, to consume. Okay, and we're looking at this production function with these inputs of L and K, which is the stock of capital in the factories. Okay. And we say straight away that F prime K is always greater than or equal to 0, which means that the more of this capital you've got, the more you're able to produce. And the same for L. But on the other hand, F double prime K and F double prime L are both negative, which means that for each extra unit of capital for a given amount of labor, it adds less to your production. So if you plot Y against K for a given L, it's going to have this kind of curvature. It's upwards, but turning flatter. Okay. And the same for L. And we also have these conditions. Well, there's various other conditions. One is that if you've got no capital or no labor, then your production is going to be 0. You need both. They're both essential. Okay, and then how do we describe this process in discrete time? We could say that kt plus 1 is 1 minus delta kt plus s yt, where delta is the depreciation rate. So you've got some stock of capital kt in the factories at time t, but then by time t plus 1 you've only got 1 minus delta kt left, because some of it went up in smoke. But you've got the addition of s yt. And then consumption, obviously, is 1 minus s yt. Okay. So that's the neoclassical growth model. Let me see. Yeah. Then there's one more really, really crucial assumption, actually, about K and L, which is that we have constant returns. Which basically means if you double both of the inputs, you will double output. So it's effectively, if you imagine you've got one factory with 10 units of capital and 10 people working in it. If you build another one next door with another 10 units of capital and 10 people, that will produce the same as the first one, and your total production will double. That is the constant returns assumption. Okay, so that's some basics about the neoclassical model. And then in the Solow model, what's special about the Solow model is that we set S as constant. The saving rate is just exogenous constant. Another very famous model, the Ramsey model, we make S endogenous. Households decide, depending on their preferences and other stuff, their beliefs about the future and so on, how much to save. But in Solow, it's constant. And typically in the Solow model, we say that this function is Cobb-Douglas. Okay, I'm going to take a pause there.